This is section 6.3, number 12 through 15. I am not going to read number 12 to you because I think it's easier just to show you the difference. We have two different things. We have row echelon form and we have reduced row echelon form. What I will tell you is that row echelon form is abbreviated REF, all capitalized. Reduced echelon form, whereas reduced row echelon form is REF. Now let's go look at the difference between them in the next example. So which of the following matrices are in row echelon form? So let's start with B. Notice that there's no column of ones at all, so this is in nothing. Let's look at C. C has this whole row of zeros in here. That means it's not in either of those two forms. Now, let's look at A. A has a diagonal that's all ones. Everybody see that? Below the diagonals are zeros, and above the diagonals are numbers. So this is called row echelon form. So A is in row echelon form. Now let's look at D. D, we have a diagonal of ones. That's good. Below it, we have all zeros. So it could be in row echelon form. But notice above the diagonals, we also have all zeros. So this is in something even more simplified. It's called reduced row echelon form. And then notice that the last column is not zeros. It could be, but it's usually not. So this is reduced row echelon form. Now I want to show you the very wonderful thing about reduced row echelon form. Remember that the first row is the X's, the second row is the Y, the third row is the Z, and the constant is the last row. So what this reduced row echelon form tells us, it tells us that 1X, which is just X, is negative 3.5. And it tells us that 1Y, which is Y, is 0.7. And it tells us that 1Z is 4.5. So it actually gives us the solution to this system. So the solution to this system is a negative 3.5, comma, 0.7, comma, 4.5. All right, let's look at some special systems. When a row consists entirely of zeros, so notice this bottom row is all zeros, then that's equivalent to saying that x plus 4z equals negative 6 and y plus 4z equals 8. So this particular system has infinite solutions. And then you can describe the infinite solutions. If I want x by itself, then I subtract 4z and I get x equals a negative 4z minus 6. And for the second one, if I subtract 4z, I get y equals a negative 4z plus 8. So then my solution, you'll see right here, is negative 4z minus 6 for the x. For the y, a negative 4z plus 8. And the z is just a z because it was our zero row. So this is an infinite solutions, and there are the solutions. And then the last example. Look at this bottom row. This bottom row is saying that 0 equals 9. When does 0 equal 9? Never. So this system has no solution.